In 2014, a submersible probe descended into the pitch-black waters off the coast of Oregon. The crew was mapping the deep ocean floor, cataloging hydrothermal vents, and photographing whatever strange life they happened to encounter. At nearly 7,000 feet below the surface, their cameras captured something that made them pause. A small, translucent creature hovering just above the seafloor, its ear-like fins flapping gently in the current. It looked like something out of a children's cartoon. Delicate, almost fragile, completely out of place in one of the most hostile environments on Earth. This was a Dumbo octopus. And the deeper you look into what makes this animal tick, the stranger it gets. See, most octopuses we know about live in shallow waters, rocky reefs, coral gardens. They're intelligent, quick, masters of camouflage. But the Dumbo octopus exists in a realm so extreme that life there operates by completely different rules. No sunlight, crushing pressure, near freezing temperatures. And yet this tiny creature, with its cartoon-like appearance, has managed to not just survive, but thrive in the deepest parts of our oceans. So how does something this bizarre even exist? The Dumbo octopus isn't just one species, it's an entire genus called Grimpoteuthis, containing at least 17 different species, though scientists suspect there are more we haven't discovered yet. They're found in every ocean on Earth, but only in the abyss, the deepest parts. Some have been recorded at depths exceeding 13,000 feet. That's nearly 2.5 miles straight down. At those depths, the pressure is crushing, literally over 400 times what we experience at sea level. For context, that's enough force to crumple a submarine like a soda can. But the Dumbo octopus doesn't have bones. It doesn't have a rigid structure to collapse. Its entire body is soft, gelatinous, filled with fluid that equalizes the pressure inside and out. It doesn't fight the abyss, it becomes part of it. But here's what I find fascinating. How do scientists even study an animal that lives in total darkness, miles below the surface, in an environment we can barely access? Well, most of what we know comes from deep-sea submersibles and remotely operated vehicles equipped with cameras. Even then, sightings are incredibly rare. The ocean at that depth is vast, empty, and the Dumbo octopus is small, usually only about 8 to 12 inches long. Finding one is like searching for a single coin in a football stadium with the lights off, but when researchers do encounter them, what they see defies expectations. These creatures move with an almost whimsical grace, flapping their ear-like fins in a way that resembles flight more than swimming. And that raises a deeper question. Why does the Dumbo octopus look the way it does? The answer lies in physics. In the deep ocean, energy is scarce. Food is rare. Every movement costs precious calories. Most deep-sea creatures are slow, lethargic, conserving energy at all costs. But the Dumbo octopus needed a way to move efficiently without exhausting itself. Those iconic ear-like fins, the ones that give it its name, are actually modified flaps of skin connected to its mantle. When it flaps them, it generates lift, allowing it to glide through the water with minimal effort. It's not swimming in the traditional sense. It's hovering, drifting, almost floating, and when it needs to move quickly, it can pulse its webbed arms or use jet propulsion like other octopuses. But most of the time, it just glides, conserving every ounce of energy it can. To understand the Dumbo octopus, you have to understand its world. Step back into the hadal and abyssal zones, the deepest layers of the ocean where sunlight has never reached and never will. Temperatures hover just above freezing. The water is still, almost eerily calm. No currents to speak of. No plants, no photosynthesis. The entire food web down here is based on one thing: marine snow. Snow is the constant rain of organic debris falling from the upper layers of the ocean. Dead plankton, fecal matter, fragments of larger animals all drifting down like a slow, never-ending snowfall. It's not much, but it's all there is. And creatures like the Dumbo octopus have evolved to make the most of it. The seafloor at these depths is a wasteland, a barren plain of sediment and rock. Visibility, if there were any light to see by, would extend maybe a few feet at best. Sound is muffled, movement is rare. In such an environment, speed doesn't matter. Camouflage doesn't matter. What matters is efficiency, patience, and the ability to exploit every scrap of food you find. The Dumbo octopus has adapted perfectly to this world. Its body is nearly transparent, not for camouflage, but because pigmentation is expensive. Why waste energy producing color when there's no light to see it by? Its eyes are tiny, almost vestigial. Some species have eyes that barely function at all. Down here, sight is nearly useless. Instead, the Dumbo octopus relies on touch and chemical sensors to navigate its dark world. And here's something truly bizarre. Unlike most octopuses, which lay their eggs in clusters and guard them fiercely, the Dumbo octopus doesn't have that luxury. Food is too scarce. Staying in one place for weeks or months would mean starvation. So instead, female Dumbo octopuses carry their eggs internally, releasing them one at a time when conditions are right. The eggs are larger and more developed than those of shallow water octopuses, giving the hatchlings a better chance of survival in an environment where finding food is a constant struggle. So here's the question everyone wants to know. What does the Dumbo octopus actually eat? Well, the answer is almost anything it can find. This isn't a picky eater. It can't afford to be. Its diet consists primarily of small crustaceans, bristleworms, and tiny bivalves buried in the sediment. It doesn't hunt in the traditional sense. There's no chase, no ambush. The Dumbo octopus simply hovers above the seafloor, scanning for movement or chemical signals. When it detects prey, it descends slowly, its webbed arms spreading out like a parachute. Then it engulfs whatever it's found, trapping it in the webbing between its arms. Some species have been observed using their arms to probe into the sediment, feeling for a hidden prey. Others appear to eat organic debris directly from the seafloor, sifting through the muck for anything remotely nutritious. It's a scavenger's lifestyle, opportunistic and indiscriminate. But here's what makes it even stranger. The Dumbo octopus has no ink sac. Most octopuses use ink as a defense mechanism, releasing a cloud of dark fluid to confuse predators and escape. But in the pitch black abyss, ink is useless. There's no light to obscure, no visual predator to confuse, so evolution discarded it entirely. Instead, the Dumbo octopus relies on its ability to blend into the darkness, to move slowly and silently, to be so small and unassuming that it simply isn't worth the energy to chase. And perhaps, most importantly, it has almost no natural predators. The few creatures that exist at these depths are either too slow, too specialized, or too small to pose a threat. The Dumbo octopus is, in many ways, the gentle wanderer of the abyss, drifting through a world where the biggest danger isn't predation, but starvation. So if the Dumbo octopus is so well adapted to the deep ocean, why don't we see more creatures like it? Well, the answer is both simple and profound. The deep ocean is one of the most stable environments on Earth, but it's also one of the most demanding. Temperatures barely fluctuate. Pressure remains constant. There are no seasons, no day-night cycles, no dramatic changes, but that stability comes at a cost. There's almost no energy, no primary production. Every calorie of food has to drift down from above, and most of it gets consumed long before it reaches the abyss. To survive here, you need to be incredibly efficient. You need to grow slowly, reproduce infrequently, and move as little as possible. The Dumbo octopus does all of this perfectly, but most animals can't. The barrier to entry is too high, the energy budget is too tight, and so the deep ocean remains one of the least populated habitats on Earth, a vast, dark wilderness where only the most specialized creatures can endure. But here's what should make us think. We've explored, less than 5% of the ocean floor, less than 5%. We know more about the surface of Mars than we do, about the deepest parts of our own planet. And every time we send a submersible down into the abyss, we discover something new, a new species, a new behavior, a new mystery. The Dumbo octopus was a creature we didn't even know existed until relatively recently, and yet it's been down there floating through the darkness for millions of years. How many other strange, beautiful, impossible creatures are still waiting to be found? The Dumbo Octopus is a reminder that life doesn't just survive in the harshest places. It thrives, it adapts, it finds a way. And sometimes in the process, it becomes something so unusual, so perfectly strange that it almost doesn't seem real. And that's the thing about the deep ocean. And it's, not just another habitat, it's another world entirely. A world where the rules we take for granted, light, warmth, abundance, simply don't apply. And in that world, creatures like the Dumbo Octopus exist not in spite of the darkness, but because of it. What are your thoughts on it? Leave a comment and don't forget to subscribe for more content like this.